This is the Intro to Stats Exam 1 review. This is page 8, our final page. So 15, we've got an adult life expectancy in a small town in Algeria following a normal distribution. So we are going to take a look at our normal curve here. And we are going to start, super symmetric on my part, sorry about that. We've got a life expectancy. There's our mean of 78.5. It goes right in the middle. We use our standard deviations to separate the population. We've got a standard deviation of 2.8. So 78.5. And I'm going to write that over here just in case the words aren't making sense. Gives me an 81.3. Sorry, decimal's in the wrong place. 81.3 plus 2 standard deviations means we're taking our 81.3. We are adding 2.8 again, which gives us an 84.1. And 3 standard deviations out, we add 2.8 again, and we get 86.9. To go the other way, below that mean, I got 78.5 minus 2.8, which gives me a 75.7. That is just not legible. Let's not make it that big. I don't want to erase everything. Let's try this again. There we go. And 75.7 minus 2.8 minus another standard deviation, and we get 72.9. And one more time, and we get 70.1. 68% of the population. One standard deviation below to one standard deviation above. And let me label this 34%, 34%, again 13.5 here, and here, .35, and then out on the tails, 0.15. So 68% of the population lives between 75.7 years and 81.3 years. What percent of the population lives between 72.9 and 86.9? So here's my 72.9. Here's my 86.9. And so I'm going to add up the 13.5. I got 34, 34, 13.5, and 2.35. So everything between those two values. When I add those together, I get 97.35%. Oops, I wrote that in the wrong place. So I am going to, just move it up. Not a whole lot of space here, I apologize. What percent of this population lives longer than 75.7 years? So here's my 75.7. So everything To the right of that is what we're looking for. When we add those together, we get a point. We don't get a 0.84. We get an 84%. Final question. We're going to use the histogram to answer the question below. We've got a histogram of gas consumption per floor area for BNNES schools. We've got labels here. The bottom is annual gas consumption of kilowatt hours per square meter per year. And on the vertical axis, we've got the number of schools. So the shape of our distribution is skewed right. We do have one school that seems to use a lot more energy than the other ones. Which would be larger, the mean or the median? The mean, because the mean is affected by outliers. And is pulled towards the tail. In this case, the right tail. We need two ways to improve this histogram so that it more accurately represents the values. So now this is a histogram. Notice that it looks more like a bar graph. So the first thing we're going to do is point out that the bars should be touching. Those bin widths have no spaces between them. So we should see something that looks a little more filled in. Would be helpful here too to have relative frequencies. And then we could see the percentage of schools in each category. Would also help if we knew here what these colors mean. Could be that it's elementary schools, middle schools, and high schools, and the high schools use more energy, but we don't know unless we have that key.